Hello, everyone. Again, welcome to another episode of the ReSES argument seminars. We are very happy to have Don Ross with us today, and he will be talking about his forthcoming book, The Gambling Animal. I will briefly introduce him, although everyone knows him very well. Just a few words on Don. Don Ross is a globally recognized scholar known for his bold interdisciplinary approach to economics and philosophy. He is an experimental economist and philosopher of science based at University of College Cork in Ireland since 2016, the University of Cape Town in South Africa since 1997, and Georgia State University in Atlanta since 2010. Don is a very prolific writer with many academic articles and books on a wide range of topics. He has also done policy consulting for public and corporate clients, including the World Bank, the South African National Roads Agency, the US Department of Commerce, and the government of Namibia. Don is the co-author of the forthcoming book with Glenn Harrison entitled The Gambling Animal. So, Don, many thanks for agreeing to give this talk, and the floor is yours.
Thanks very much, Emra. Thanks very much for organizing this session. Thanks to the panelists here and anyone who's tuned into the webinar. I can't see who you are. I can't see the webinar audience while I'm in this display mode, but I'll find out at the end. This book, which I'm going to be talking about today, is a trade book. It's a commercial publication, so publishers take a lot more interesting in marketing in such cases than academic publishers do. So I will do something I wouldn't normally do, which is draw your attention to the website at the second link here on this screen. If anyone is in mind, my publishers who will see this webinar will want me to draw attention to that, because that's a site you can visit if you'd like to order the book. Or, of course, you could do that on Amazon as well. Okay, so marketing obligations duly discharged. Let's talk about the book. A couple of cautionary notes before I start. First, the book is co-authored with Glenn Harrison, my regular collaborator over many years on many papers and activities, including our current ongoing experimental field work with a group of elephants, African elephants, and that's lightly reflected in what I'm going to talk about today, but I'll come back to briefly to our elephant experimental work at the very end of this presentation. Another cautionary note, the book is about 400 pages long, and I've squeezed this overview into just over half a dozen slides. So obviously, I'm going to be passing over a lot of material that is in the book. To try and survey the 400 pages in a short time would be such a high-level view. It would be boring. We would just be seeing the broadest outlines. We wouldn't be able to distinguish any specific features. So I've tried to cope with that in a couple of ways that you'll see. But bear in mind, this is a very incomplete or impressionistic view of the overall book. And finally, this is the first time that I've done a presentation of this material. I've got a whole marketing tour coming up in Cape Town in a couple of weeks. So this is kind of a warm-up exercise for me, and I'll ask you to therefore bear with me that there might be some gaps that won't occur to me until here we are doing it. And I'll be grateful to you for pointing out in question time where you see gaps. Undoubtedly, it'll be reflected in your puzzlement at some missing steps in an argument. Because I've kept the slides brief, I'm hopeful that there will be a good time for questions at the end, but there won't be if I don't get going. So let's start. I'm going to begin with a couple of slides that just present the grand themes, as it were, of the book. That is, themes that run right through the book, passing over many digressions and other issues we go into in specific chapters. And then after those two slides, I'll go back and review those same themes in a little more detail. That is, I'm not going to go and fill in at any point, fill in all the various digressive steps. You'll get the big themes just laid out, and then I'll explore those big themes with a little bit more detail and motivation and justification, and show you a bit more clearly what the basis of the claims is. So here then are the main themes of the book. We start, I should add too, we are economists mainly, and in particular, we're economists who specialize in the study of responses to risk. That is, over the course of many years of empirical work, we've now estimated the structural risk preferences of a bit more than 40,000 people all over the world, men and women and weird people and people in developing countries and numerate people and innumerate people, literate people, illiterate people, students, of course, lots, but all the way up to including chief risk officers of companies, a pretty good cross-section of the population. And now we're estimating the risk preferences of elephants, the structural risk preferences, using an adaptation of our standard experimental protocol with people that we can use with elephants in an outdoor lab. As then people who are preoccupied with risk as an explanatory frame, we are struck by a puzzle. Most individual humans, so the overwhelming majority of those 40,000 plus people I just mentioned, and also based on extensive, well, much less extensive, but some work with other animals, are and always have been, as far as we can tell from evolutionary history, moderately risk averse. And there are very strong models in applications of game theory and abstract economic logic to the evolutionary trajectories of animals in general. There's good reasons to understand why natural selection would tend to select for risk aversion. But when we look at the history of our species, we find that humans in groups, large groups and smallish groups, have consistently chosen as if they were risk neutral or risk loving. So we find overwhelming evidence that individual people are risk averse. But we also find very strong evidence that when you gang them up, they act as if they choose as if they're risk neutral or risk loving. And that is not something we find in other animals. So looked at when we naively approach humans as risk scientists, this is the puzzle that strikes us. This is this is what calls out for some kind of explanation, evidence-based explanation, of course. All right, now another theme that we explore in the book, as in drilling into some of the bodies of evidence that would be relevant to explaining this puzzle. Another thing, we go all the way back to the Neogene. So we go to the deep evolutionary origins of humans. So we go well back before Homo sapiens or even before Homo erectus. And we trace the multiple stages of encephalization in people. And when we go back, we don't have to go back very far in our evolution. Arrive at some hominins who did not have greater inboard cognitive processing power than elephants. We're going to, I should add, use elephants as the comparative foil with people all the way through this work. The basic reason for that appeals to convergent evolution. That responded to more or less the same risks our ancestors did at more or less the same time in more or less the same environment. So elephants are our foil for that reason. And when you go, again, if we go back far enough, we don't have to go back very far to find a time when from a purely cognitive processing power point of view, our ancestors and the ancestors of modern elephants were on the same footing. And we spend quite a lot of time in the book reviewing the evidence to suggest that the relevant sequence here in our evolution, in human evolutionary line, was not that first we developed much more powerful cognitive processing, inboard cognitive processing capacity, and then on the basis of that, developed the crucial tools, the crucial components of our collective response to risk. In general, the earliest killer apps, as it were, that distinguished us most strongly from our comparative basis, both our nearest relatives among the apes and also from elephants. These early killer apps that are absolutely crucial in setting us along our ecological trajectory, namely control of fire, establishment of long-distance trading markets, and expansive morality on narrow dimensions. That is, expansion of tribal morality, of just enough tribal morality to allow us to establish long-distance trading relationships. We find gradual emergence of those features of humans in the evolutionary line before we encounter the full flowering of what we now think of as our cognitive sophistication in the form of civilization. So these are building blocks for the and that's where we don't see the significant special collective risk taking until quite late in the human career, until after we've got the basic structures of civilization in place. So it's not a simple matter of we were smarter and therefore blah blah blah, right? We argue in the book a kind of thesis in a way which will be familiar to many people here today. That is, we take a strongly externalist and scaffolding-based view of human intelligence, that our intelligence is substantially based on the fact that we've constructed our environment to scaffold the particular form our intelligence takes. So we don't just rely. The story isn't, you haven't begun to complete the story if you just point out that we have a lot of neurons. I'll come back to that in more detail. Here's the key point. These crucial building blocks arose prior to civilization. They all arose as responses to rapid climate change pressures that our hominin ancestors were under in the Pleistocene and in Africa. We start to see the special kind of risk-taking when these building blocks are stitched together to form the basics of civilization, specifically human civilization. When we spend a good deal of the book comparing human and elephant brains, because obviously, though we are by no means, quite the opposite, reducing intelligence or behavioral patterns to a neuroscientific basis. We think many of the most crucial differences between the trajectories of humans and the trajectories of elephants with respect to risk management, and therefore ultimately with respect to ecological success. Many of those fundamental differences are emergent manifestations of, they're consequences of the very different kinds of brains that humans and animals have. Then these brains, of course, set into a common environment facing similar risks. So that's the story of that part of the book. And the conclusion of that part of the book is, or the crucial facts about brains that are exploited in that part of the book. It's not the conclusion, it's a crucial part of the story. Humans acquired more powerful imagination as they encephalized, which allowed them to frame novel strategies. But as we argue at considerable length and with considerable detail in the book, at the cost of potentially losing and often actually losing our grip on reality. Humans became highly imaginative and also crazy. And what we characterize as the insanity problem forced us to tyrannize ourselves using social control. Individual human beings, as a result of the kinds of brains they have, are basically at risk of becoming lost in fantasy. And it's social control that prevents individual humans from succumbing to that. And we explore an indicator of the odd brains that we have by comparison with elephants, which is our strange sequence of technological mastery as civilization developed. Despite the fact that we have, in a relevant sense, identified by Carl Friston and many others, and Andy Clark has had a lot to say about this, despite the fact that we seem to have, at one level of description, basically Bayesian brains, and despite the fact that both long-distance trading and recreational gambling are very ancient in the human behavioral lineage, so despite the fact that we have an apparatus that can deal with statistics in some sense, process statistics, and despite the fact that we have been confronting statistical evidence in some of our core activities for a very, very long time, peculiarly, when we did develop science, after developing, of course, writing, we developed theory-led science before we understood statistics. The proper understanding of statistics followed the beginning of the scientific revolution by 2 centuries. In the book, we do an extended thought experiment in which we imagine how elephants would likely, we try to tell a plausible story given the nature of elephant brains, elephant ecology, and elephant social dynamics. We try to tell a plausible story about how elephants might have developed civilization if we had not developed it first and thereby crowded out their chance. And one of the conclusions that our thought experiment leads us to is that if elephants had developed writing, and on the basis of that gone on to develop civilization, well, fully scientific industrial civilization. You don't need writing for civilization, but you need writing for our kind of modern civilization. If we argue that if elephants had developed writing, they likely would have progressed in the opposite order. That is, they would have developed statistics first, and would have been led slowly, perhaps, to theory-led science on the basis of that, whereas we went in the other order. And that order is peculiar. And we think the elephant order, in some sense, is more natural. And finally, the last of the main themes, the big themes that run through the book, we show or argue that the history of humanity has the structure at wide remove of what we call a risk ratchet. That is, that we collectively manage risk through scale expansions. We take a relatively small scale risk, and we typically cope with it, or we manage it, by expanding the scale on which we bundle it, in effect, with other risks. We, at a species level or a group level, we are constantly forming ever larger portfolios of risk and coping with specific risks by bundling them into packages of larger risk. But every time we introduce new technology in order to be able to keep creating these larger portfolios, we then create harder to manage scale new risk sources. And we follow the emergence of this ratchet through the history of human civilization in some detail, and argue that this tendency for our risk management to keep generating ever more larger scale and ever more difficult to manage risk is a relevant way of understanding our current predicament, right? Which is that we now, in the form of climate change and the threat of biodiversity collapse, we now face, for the first time, a common risk. Well, not quite the first time. Nuclear weapons, of course, were an early one, but specifically where climate change and biodiversity collapse are concerned, we face a global scale risk, all at the same time, that affects everybody at once. And in that sense, is both there's sort of no further way to scale it up. Our standard historical strategy can't work anymore because we've reached the limit. And then, of course, makes our current predicament extremely problematic. And I'll say something, of course, a little more about that at the very end of the presentation. So those are the main themes of the book. This is what the book is doing. It's really a convergent evolutionary study of humans and elephants from the point of view of social evolution and social risk management. And it's the point of the book is to look at human evolution through this specific lens. We, of course, do not claim this is the only way to look at human evolution. There are lots of other angles that are at least as important, but we think this is an unexploited one, and it's the one that you take up if you're a risk scientist. All right, so now into those themes again, recapitulating those themes, but with a little more detail. Let's start with the brain stuff. One feature in which humans and elephants are relatively special, not uniquely special. I mean, similar point applies, for example, about cetaceans, but elephants have much more metabolically expensive brains than our own nearest living relatives. So the elephant brain is significantly more metabolically expensive than the chimpanzee or the gorilla brain. If we take all the living mammals, all the living land mammals, again, set cetaceans aside, humans and elephants share the situation of being kind of off the chart with respect to the metabolical expense of our brains, which again, of course, is a suggestive fact to inspire a convergent evolutionary examination. But the structures of these highly expensive brains are quite different. What makes the human neural kit so costly are the very densely packed frontal cortical neurons. Right? They're responsible for the majority of the special extra cost of the human brain by comparison with the cost of other ape brains. By contrast, the costly elephant kit, so the source of the metabolic cost of the elephant brain, is in very densely packed cerebellar neurons in cerebellum. And the nature of information processing in frontal cortex versus the nature of information processing in cerebellum leads to a crucial cognitive difference in cognitive style between the two species. Because, right, if you've got very densely packed frontal cortex, it means that most of your neurons are connected only relatively distantly to neurons that respond relatively directly to perceptual information, that are relatively distantly connected to any kind of environmental transducers. And so most of our neurons are processing information that is relatively removed. It's about mostly other neurons and other neural structures. And so this is the basic structural property that makes us so susceptible to fantasy and craziness. That is, we have difficulty distinguishing our models of reality. We have difficulty of distinguishing features of our models of reality that don't actually emerge from reality. By contrast, cerebellum is basically a system for using the position and trajectory of the physical body to serve as a memory model, to store information about the organism's history. And having so much extracerebellar capacity is what explains elephants' extremely stable memories. I'm avoiding saying elephants have, photographic episodic memory because nobody has that. All brains are dynamic systems and they don't have hard storage. But it is the case, as anyone who works with elephants knows, that you can surprise an elephant by varying in detail that they only observed once several years ago. A kind of surprise you can't induce with humans because they don't remember that. They don't remember at that level of granularity. So, and what this really points to is stability of memory over time rather than right, one shouldn't use a metaphor. One shouldn't use a Cartesian theater metaphor here. But it's true. right? Elephants are much less likely to have this insanity problem because they are more reality based. Now, we explain and argue in the book that building external cognitive scaffolding, ultimately filling the world with signs, initially, of course, in the human case, drawings um, and stereotype gestures that could be passed among people across generations and also between human cultures. Filling the world with signs was our way of coping with the huge risks associated with our tendency to insanity. And of course, this tendency to insanity is never perfectly controlled. We see still many, many manifestations of it, and it's possible that our recent information processing innovations, our recent innovations in information processing technology have brought this problem back to the forefront in a really difficult way. But elephants, we argue, one of the reasons why it's not so surprising that elephants never evolved writing, even though you can relatively easily teach elephants to draw. But they don't draw naturally. They could, but they don't. They're not missing the tools. They're not missing the ability to manipulate the tools. Right? They can draw with sticks in the sand, in the soil, but they don't do it. And of course, they don't have writing. One way to understand why they don't is they weren't under any pressure to. If you've got very stable memory, you don't have to store your collective memories in external scaffolding the way we do. Continuing the convergent evolutionary story, we look at the comparative demographic history of humans versus elephants. After developing their specific response to the climate change pressures of the Neogene and then the early Pleistocene, that is, after developing some crucial shared properties, dependence on mobility for sourcing food and water, and having special adaptations that facilitated long-distance mobility. And after both species had evolved a very long-lived ecology, involving in particular long childhoods and alloparenting, shared parenting by adults of highly valuable, metabolically expensive children. After developing that common ecological kit that's shared between the two species, since mobility was the fundamental adaptive characteristic of both, unsurprisingly, both expanded, and quite rapidly. Both indeed expanded across the continents, both hominins and elephants. And if we drill into what is known about the historical anthropology of both species, we see over and over again the specific migrations of both species are driven again by the volatile nature of the Pleistocene climate. But if we also compare the dispersion of the two species in terms of the extent to which this was a successful strategy, that is, the extent to which this strategy was simply expanding the populations of the species, it initially worked much better for elephants. Right? Until about 50,000 years ago, elephant numbers were climbing at a much more steeper rate than human numbers. If we go back to just beyond 50,000 years ago, there are 100 times more elephants in the world than people. So elephants are a common species on multiple continents. Humans are a relatively rare species. We're all over the place, but we're marginal. Our populations are marginal, and about 50,000 years ago or a little earlier, we suffered a global population bottleneck. And if one could go back in a time machine and wipe out knowledge of what happened afterwards, and one just took a kind of snapshot of the global comparative human and hominin evolutionary success at that point in time, one might well think humans are not going to make it. Right? There's these population bottlenecks arise frequently enough at all the human locations that one can just do a kind of Bayesian exercise and calculate what our chances of extinction were if we stayed in that kind of state, and they're high. Whereas elephants looked very, very well established. They had their migration allowed them to cope well as a global species with the unpredictable nature of the glacial cycles through this period. But then one population, concentrated mainly in southern Africa, we of course had begun in East Africa, East and East Central Africa, but it was a population in southern Africa that developed the basic technologies of civilization and enjoyed the last phase of special human encephalization. And on the basis of that, then triggered a second wave of dispersion, global dispersion. It was much more successful. The second dispersion, we dispersed in substantial numbers, and where we settled, we usually significantly expanded populations when we showed up. Ultimately, of course, elephants, of course, not having experienced that second evolutionary event, have no parallel phenomenon, ecological phenomenon, and ultimately this more successful human expansion crowded elephants out of most of their environments. And of course, we reach the situation now where there are very few wild elephants left, and heading for 10 billion people. From here, we focus now mainly on people. The elephants at this point in the story have lost. Now, getting to this, I should stress that here in this talk, I got to this part of the story in 8 minutes. In the book, we're now a good 250 pages in by this point. And we'll come back to the elephants one last time at the end. But now that humans were the apex species, became the apex species, ecological apex species, relatively quickly, starting about 50 to 40,000 years ago. From here on, we follow the evolutionary story, the cultural evolutionary story of human risk from that point. And we focus on a number of what we call the great human gambles, the first being the adoption of agriculture. Following a number of other authors, this is not really a line that is original to us in any way. We argue that the adoption of agriculture was a kind of tragedy. That is, it was a tragedy of timing. The evidence seems to be that humans, at multiple points, agriculture wasn't invented in one place and then spread. It was multiply invented over a long period, relatively expansive period of time, but relatively expansive. I mean, it arose lots of places in a fairly, in evolutionary time, short period. In general, people turned to agriculture at the end of the extremely unusually volatile Berling-Allerud period, when patterns of glaciation had been particularly rapid and consequent climate and weather changes had been very volatile. And probably as a variable range of desperate measures, as different forms of agriculture were adopted in different places, suited to the specific ecologies of those environments. But it was a variable range in each case that we studied, that archaeologists and anthropologists have studied closely. It seems to have been a kind of desperate measure taken to cope with extremely difficult conditions. And furthermore, in general, all these various human civilizations were doing this just as, unknown to them, the nice Holocene was just starting up. And so we suggest in the book that because our ancestors, of course, couldn't know that the starvation risk generated by the climate volatility of the Berling-Allerud was coming to an end, And in effect, we took up agriculture just when we didn't need to. But of course, we could not, our ancestors could not foresee the future or plan in a collective way. And the result of, and then of course, a story that's been made familiar by a number of authors over several decades. The result was an explosion of new risk, new kinds of risks that arose from population concentration and stationary lifestyles and lifestyles in close proximity to domestic plants and animals, particularly domestic animals. An explosion of new risks from disease epidemics, from poorer general health as a result of less varied diets, devastating wars, because now with agriculture there was territory to be fought over and larger populations and greater social hierarchy, so elites could recruit non-elites as soldiers. And the widespread enslavement to social machines that generated boom and bust civilizations. And of course, by social machines, I refer to relatively hierarchical societies with, again, elite management. There is a growing, so that what I've just been talking about will be familiar probably to most people in the room because it's been well explored again for some decades. The nature of the shift, the risk shift, and in people's lives when we go to agriculture. Newer work by ecological anthropologists looking in closer detail at the specific histories of specific climatological coping mechanisms by early agricultural people, find that there tends to be a pattern that they observe over and over again, which is people will, and this is the risk ratchet I alluded to earlier in the talk, people would cope with an ecological threat by expanding the extent of their cultivation land and then driving the relatively non-elite exposing the relatively non-elite populations to the most intensive risk in the most vulnerable areas. Because of imperfect sympathy of preferences between elites and non-elites, that tends to produce a pattern in which the elites drive the non-elites to overexploit the environment as a whole for the benefit of the elites. And ultimately you get collapse in the wider area. So you start with a small area, you cope with risk in the small area by expanding the area. But you also, given the nature of the social dynamics that tends to produce that and co-evolve with it, culturally co-evolve with it, you ultimately get collapse of the whole system. So collapse in these fragile, and one way, of course, to collapse risks, that kind of ratchet, is again, just expand the whole story. Massively expand your trade networks. To massively expand your trade networks, of course, that incentivizes massive expansion of military networks to protect those expanded trade networks. And so in many parts of the world, not all, but in many parts of the world, we see the collapse risk in these fragile civilizations giving rise to empires. But now, of course, the kind of risk confronted when you have an empire, which is a strong risk control mechanism relative to that more local kind of climate risk, has this ratchet property, right? The empire manages the local risk, but when the empire collapses, you have a truly catastrophic risk consequence. And indeed, nothing was worse until very modern times, until modern technology for people. Nothing was ever worse for more people in terms of their basic welfare measures than living in a collapsed empire. In every case of empire collapse, the body count was gigantic. And of course, often there would be regression with respect to knowledge and technology. And all empires did eventually collapse. No empire was forever. The great risk management responses to empire collapse that ultimately produced a different kind of cultural ecology in most of the world were science and then much later industrialization. We spend a chapter looking at the relationship between capitalism and industrialization as risk management technologies. We identify capitalism with the creation of financial institutions to separate investment from production and mercantile activity. So it's not a Marxist analysis of capitalism, but one that's more common among non-Marxist economists. This is what made industrialization possible. We argue in some detail that the development of when we look at the details of the development of capitalist institutions, beginning with maritime insurance provision and working up to full-fledged banks, first in Holland and then spreading from Holland throughout the world. This is yet again we see the pattern of the risk ratchet. We see a strategy that creates larger risk portfolios by building new institutions and regulations to accommodate them, but as it expands the risk, it reduces the portfolio held by the population as a whole, and thus increases the total risk. Following Jeff Hodgson's recent work, we look at capitalism as having been mainly fostered throughout its evolution by deliberate regulation and corporate law. It didn't, as it were, grow endogenously and organically. And we focus in particular on a decisive step, namely the emergence, very late in the day, first in the United States, in fact, of the limited liability corporation. The reason this is important in our story is it's the limited liability corporation that directly incentivizes directors to be risk neutral, since they're able to offload the downside of the risk and while carrying the full or most of the upside risk, concentrating the upside risk in their own hands. We have in modern corporations risk neutral machines, but risk averse people who need credit and life cycle insurance from these machines and are thus forced to participate in them, right? Therefore have to entrust their savings, in particular, they have to entrust their such savings as they can generate to these machines. And so here we have the modern solution to the puzzle I started with. Risk-averse individuals are basically forced in modern industrial civilization and capitalist civilization to entrust their savings to machines that are not risk-averse. And so everybody, that's one sense, not the only sense, but it's one sense in which all people have to behave in risk-neutral ways or even sometimes risk-loving ways, even though when you take them out of the collective environment and put them in the lab where they're just making decisions for themselves, they're risk-averse. In general, we argue in the book when risk-averse people, whether in financial planning regimes or in casinos, and based on our extensive years of study of gambling and gambling addiction, we have a chapter on how, when we were looking at the microstructure of human risk response, we focus on casinos and how humans behave in casinos. In general, when we find risk-averse people in any environment, so casinos are the micro-scale setting, the modern capitalist economy is the macro-scale setting, but in both cases, where risk-averse people behave as if they're risk-neutral, it's because we find a social machine that is inducing it. We conclude the book with a fairly long chapter on our current predicament. So we've been running this risk ratchet since the beginning of our species, since before the beginning of our species. Now we've clearly faced the risk of civilizational implosion due to the risks we have created. And of course, those risks, mainly through climate change and biodiversity collapse, are compounded by the fact that more particularly recently, we've recklessly and without much thinking hacked our main information management system. That is, we've largely destroyed informational gatekeeping and allowed information to flow with no management. Given our natural disposition to fantasy and insanity, arising from our difficulty of distinguishing reality from imagined reality. This may also contribute to a level of destabilization that could lead to civilizational collapse. I should say here that unfortunately we finished our book. We submitted our final manuscript about 5 weeks before the appearance of a slim but lovely book by the excellent policy economist Wim Nodier on the civilizational collapse risk resulting from climate change. It's unfortunate we couldn't take that book into account when we wrote this chapter. Our chapter would have been cleaner and crisper if we had, but I recommend Wim's book. Now, a lot of literature frames these problems as whole planet collective action problems. That is, looks at the climate change problem as a whole planet collective action, or the biodiversity collapse problem the same way. That leads to a certain kind of pessimism that we think is not helpful. That is, right, if climate change problem is a true tragedy of the commons, then we're buggered, right? Then there's no solution because that's not soluble, institutionally soluble. However, that isn't the way we prefer to frame the problem. That is, we don't prefer to frame the problem as a giant tragedy of the commons. The reason for that is if you actually do the math to frame the problem as a tragedy of the commons at that scale, when you then try to decompose the problem into a problem faced by any particular agent, the various properties you need for economic modeling, and in particular the game modeling you're trying to do, don't carry over down to the smaller scales. You can't hold on to, for example, monotonicity of your preferences. You can't hold on, or let alone something stronger like convexity. So you can't take the big scale problem and mathematically decompose it into smaller scale problems. But clearly what actual agents confront are the smaller scale problems. So we think it's not helpful, analytically or otherwise, or politically, to frame the climate change problem as a single giant collective action problem. It's many smaller scale problems, and it's at smaller scales we can assign identifiable risk management options to identifiable real agents, to firms, to clubs, to cities, to professional bodies, or even in the case of very, very rich and powerful people, some individuals. Now, of course, if we recognize that these problems are not single scale problems, but many, many, many smaller scale problems, then the natural cautious prediction is that some of them will be solved successfully. That is, some of these risks will be successfully managed, and many won't be. And of course, the problem is that if, to the extent that people try to solve the smaller scale problems in the way that our species historically has, by scaling them up, well, now there's no room to scale things up anymore. All you do is crash your small scale problem into the neighboring small scale problem. We can't, as it were, keep our smaller scale problems isolated in the way we historically generally could and did. We think it likely that existing global civilization, that is, insofar as it makes sense to think of the current, of all the current people, or almost all the current people on Earth, as constituting a single civilization, through shared information, shared cultural icons and norms. We think that that global scale civilization is probably not sustainable. On the other hand, we think it's highly likely, overwhelmingly likely, unless we do ourselves in with something like a nuclear conflagration, that some smaller scale civilizations will survive whatever harm we do through overheating the planet. But of course, we see no particular reason to think that those smaller scale civilizations will manage the new risks they face in a new transformed world any differently than the way humans have handled their risk in the past. So what we would expect are new risk ratchet processes to be generated. I guess there's a kind of eternal recurrence theme you might be seeing here. Okay, last closeout. a lot of our reflections on elephants in the book come directly from our close work with elephants. And I should say that I'm also engaged with other academic partners in a separate project around elephant conservation in Africa, around new novel approaches to the economics of elephant conservation. So I spend a lot of my time thinking about and working with elephants. At our outdoor lab in South Africa, we're working with a team of free-ranging but tame elephants. And we think of ourselves as teaming up with those elephants to study risk together, in the sense that our work is focused around trying to develop a common communication bandwidth by which we can share information about quantitative risk problems with them and get feedback from them. So we're exploiting the fact that elephants are naturally good at statistics to try and establish a two-way communication channel about risk with them. And that's what the research. Ultimately, there's a policy goal. The elephant population in Africa is not sustainably distributed, in the sense that there are too many elephants, too many of the elephants. I don't want to say there's too many elephants in any one place. That doesn't quite make sense, but there are too many of the elephant, for the sake of the risks they face, are concentrated. And there are too many areas which are encountering special kinds of ecological risks because they have no more elephants. So there are a number of reasons why policymakers and conservation policymakers favor more even distribution of elephants. How do you get thousands and thousands of elephants to move long distances? You can't put them in lorries. You can't chase them and scare them. You have to induce them to move the same way we try and induce people to move when we want them to. We have to make them an offer. We have to provide them with information about a better environment. A better environment to them means a less risky environment, or environment where they can cope with the risk using their normal social mechanisms. So we've got to be able to communicate about risk with them. There's a whole, of course, detailed idea here, which I don't have time to go into. That would be a talk in itself. That is relating the kind of work we're doing in our experiments with the ultimate technology we hope to develop for working with elephants on their risk. And we're in very early primitive stages of that project. But that's how at least me and my colleagues are trying to cope with our little special corner of the human ecological risk problem, and doing so with another species. Okay, that's the end of my slides. I'm sure there is lots of puzzles. There's quite a bit of bafflement out there about many things I had to be quite quick with. So I hope there'll be some time in discussion to address those sources of puzzlement. Thank you very much for your time and attention.
Thank you, Don.
Perhaps we'll leave the slides. Actually, I'll end the slideshow part so I can see more details. But if we need to go back to a slide, we can do so within the other display.
Thanks very much. This was excellent. Yes, questions. I guess Michiru had a hand.
Yeah, thanks. It was wonderful. So I have two questions. So one is about this delusional kind of feature of humans. And usually the story is used in a slightly different way, that we have this kind of a capacity to imagine and believe in some kind of collective myth. And that was supposed to be a good thing to achieve large-scale cooperation. So in a way, in the second arrow in that slide, you kind of mentioned that you need to suppress that socially. And I think that story comes back when you say that now this information is spreading unmonitored, then we are scaling up the risk. So that's exactly so this forced us to tyrannize ourselves using social control. But seems like this kind of a large-scale social control is possible precisely because we believe in this kind of a nation state and that kind of fantasy. So how do you explain that connection to this more standard story of collective imagination. And then the second question is about the role of fossils in the whole story. So when you provide us with the dark story of how how new surviving civilization will face the same structural problem of risk ratcheting, I guess when, let's imagine in 2000 years we don't have anything to burn, then maybe we cannot ratchet the risk in the same way as we have done. So maybe that might save us meaning like Homo sapiens. So these are two questions I had, but otherwise super exciting. I'm looking forward to reading the book.
Great, thanks, Mr. So I'll take the two questions in sequence. On the first question, I mean, to some extent, right, this is a glass half full, glass half empty argument. We certainly agree that it's because of the way in which we scale up our leverage, that is, as we use imagined social structures and social myths, exactly as you said, to create larger groups, we increase our capacities. And without the collective risk management history I described, most people would not live as long as they now do. And we should not imagine that if people were still mostly hunter-gatherers, this would be like some sort of hippie Eden because they wouldn't have any electric guitars. So, I mean, lots of good things, including most of the things that most of us treat as crucial good things to our lives, resulted from the way we have scaled up our social control and our social leverage. But that's why, as I stressed, one of the main things going on in this book is just standing back and saying, what does all this look like through the specific lens of risk? What does this look like? How would you look at the human civilization if you treated it as a kind of corporation and you were a risk officer? And what you saw would alarm you, right? You would see this tendency to keep dealing with manageable risks by making bigger risks at a higher scale. And when you tried to model this process, you would also realize it can't go on indefinitely, because there comes a point where the risk can't be portfolio, where you can't put anything more. You've got where everything's in the portfolio, and so you can't spread it anymore. And at that point, it looks like this method of coping with risk is not going to work anymore. Now, your second question, in terms of the speculation at the end, well, of course, it is pure speculation, and lots of other possible speculations are every bit as good as ours. If we now try to imagine a period in which global human civilization is gone, and we are now looking again at a scattered set of civilizations, I mean, obviously, that at that point, the stress that is heating the climate will massively abate. Right? One of the ways we can avoid boiling the planet is to have civilizational collapse earlier rather than later. Right? In some sense, the sooner it comes, the less hot we make the world. And that will be good for those people. You point out that, well, maybe they wouldn't repeat the specific way in which we are making this planet uninhabitable, because there might be nothing left to burn, although that doesn't make sense. I mean, I think the prospect that we will actually use up all the fossil fuels is zero. I mean, if we do, we boil long before we get to that point. Right? So that doesn't really I don't think that conjecture makes much sense. But I'm not necessarily supposing that new civilizations would walk through the very same risk ratchet that our actual contingent history has taken us through. They will be different people in different circumstances, and there's a limit to how much one should try to speculate about details when we're so far out when we're so far out away from anything from which we've got any evidence. But the suggestion is just that, look, if there's one thing humans in general at multiple scales keep doing over and over and over and over again, wherever you look, it's this ratchet thing. So their ratchet might not involve fossil fuels, but future ratchets will. I would predict that future people in radically different circumstances will find some other way to get on a ratchet, to drive a ratchet.
Thanks.
Thank you. Any other questions? We have about 50 people, so I guess there are questions. Okay, maybe yeah, Aki has a question.
Can you hear me now?
Yes.
I don't know how to make myself visible. Anyhow, I was just thinking about the detail on mathematical decomposition of the climate change problem, for example. So I'm just wondering what you mean by this, because I guess the climate change is describable as a commons problem mathematically.
Mhm.
And so are you referring to the fact that the incentives at the smaller scales are different from this description, or are you more pointing out to the fact that in the smaller scales the solutions don't look like as they would in the macro scale of the commons problem?
Thanks, Aki, for that good question. I'm making a more abstract point, but although it's abstract, precisely because it's quite abstract and quite general, a lot follows from it. The point, because it's abstract and general, is quite powerful, right? Which is, if I frame a situation as a game, I of course have to specify agents. I have to specify utility functions. I have to specify strategy sets and outcomes. Now, the utility function specification relative which you could frame the whole climate change problem or climate management problem as a single large-scale collective action problem, right? I need to make sure those utility functions are specified in such a way that I can actually do economics with them, or solve the game. That is, I need to make sure they broadly have a structure of capturable by generalized revealed preference, right, by GARP. In particular, right, because I need those properties in order to be able to well formulate the game and model it. Now, there's no point, it's not useful to frame a game for policy purposes unless the solution or the analysis of the game assigns particular actions to particular agents. You can imagine how at the global scale that might work, right? So we might say all 10 billion people have to stop eating beef. So there's something so now we've specified the agents, each of 10 billion. I guess we don't have to, I guess not each of 10 billion, because the people who are already vegetarians or don't eat cows, they just have to choose the status quo. But anyway, that doesn't matter. The point is you can at a large scale say what specific agents need to do. But then of course there's a whole bunch of things that this will be a useless solution because the range of things that everybody has to do will be very small. What we actually, of course, we would need to do to mitigate climate change is various differently positioned agents need to do many different things in different circumstances. And each of those different things depends, as always in game theory, on what various others are doing. Now, if I try to take the big game and decompose it into small games, if it's a true decomposition, then there are various specifiable properties that have to hold as I decompose. In particular, I've got to decompose in such a way that the structural features of the preference I relied on at the big scale are preserved as we go to the smaller scales. But you just have to look at the general literature on preference modeling to see how completely implausible it is. Right? One of the those crucial properties you need. I mean, the weakest possible property is just monotonicity as we go down. Most interesting game theory analysis or economic analysis requires something stronger like convexity. So as I scale down at those I better be able to preserve those properties. But in general, those properties don't travel well under decomposition. So here where I'm imagining taking an enormous problem and trying to decompose it into many, many, many problems at multiple scales, I'm going to be in analytically intractable territory for sure, almost immediately. Well, then the point is not that we can't model the large scale problem. The point I'm making is that it's useless to model the large scale problem at that scale. It's useless because we won't be able to identify any actual equilibrium policies for specific agents that they might actually, that would work. So useful modeling has to be at smaller scales.
Thank you. I was also a little bit puzzled with this part of the talk. Then would it be correct to say that you are not saying that like climate change is not one big problem? You are saying that like our approach to it, if we want solutions, should be different in terms of how we model it. Because now I get it. Because if I look at it, like it's exactly perhaps what tragedy of commons at this scale would mean. The agents don't have all the information. They are interacting with different parts of with different constraints and under different institutions, so that it's very difficult for them to see like what will happen at the like macro level. So it's still a tragedy of commons problem, but from a post perspective, we should not model it and approach it that way.
So I don't know if I want to say it really is a tragedy of the commons problem at all, right? Because it seems to me, what is the basis for saying there's a fact of the matter? I'm going philosophical here, right? What's the basis for saying there's a fact of the matter about what game a situation instantiates? Well, it seems to me the basis is the modeling the situation as the game in question has a point. One of the things that makes the traditional classical tragedy of the commons game interesting and useful to think about, right? One of the crucial features there, if you're imagining, firms that could all pollute in the same river, or the classic case, shepherds trying to graze the common, with a commons and a grazing problem. One of the features that makes those models worth bothering with is that the strategy sets are very small, right? So I can solve those games. Right? If the only problem faced by those shepherds is how to graze their sheep, and they either must graze their sheep on the commons or not, right? That's the game space. Then of course I can arrive at all sorts of interesting facts about that situation they're in. Among those facts, of course, is that if there's no, they either need a Hobbesian solution or an Elinor Ostrom solution, right? And that's a substantive thing to know about that game. But at the global scale where it seems to me at the global scale where climate change and biodiversity threat are concerned, there's no useful model of that situation in which there is a small strategy set, right? There's no useful model of that situation in which the problem, the actual problem faced by actual agents who can do something about it, has the relatively simple structure of the tragedy of the commons. So then I'm inclined to say, on what basis would you say it's a tragedy of the commons then? right? The fact that you could do some kind of radical idea. One can imagine various strategies for radical idealization of the problem and radical simplification, get the strategy sets, small and so on. But you're not taking the problem seriously when you do those things, right? You're not actually you're just changing the subject. So I'm inclined to take the hard line here and say there's no really particularly good basis for saying it's a tragedy of the commons. Or
Okay.
that even that it's one collective action problem. What we have are many, 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 many collective action problems, all of which have arisen from something we've done at the species level, which is basically adopted this particular energy technology everywhere.
Okay, I see now. Thank you. Teemu has a question.
Yeah, thanks very much. It's fascinating. I was left a bit wondering how the facts about the brains of human and elephants, what the role of those things are is in this story. So did you suggest that the tendency of humans to do this risk ratcheting behavior is somehow explained by the facts about the brains?
Good, yeah, excellent question. We do, and that's an issue we spent quite a bit of. By the way, I want to make sure I didn't cut you off. Was that?
Yeah, that was it. Yeah.
Okay, good. So yeah, we spent a fair bit of time in the book on developing those relations. We want to be very, very careful here and of course, this is a book this is a book that's supposed to be written for the general scientifically literate community. So we also have to sometimes work a problem harder because we can't just help ourselves to academic language and we can't just deal with the problem with a barrage of citations. In some ways, of course, that discipline is really helpful because you have one thing about writing. If to people in this room who have never written a trade book, as I remember hearing Eric Agner point out once, it's a fabulous discipline to make sure that you are thinking decently clearly. But anyway, on the question itself. So the basic idea here is we want to explain why it is. We take it as one of our explanatory burdens to explain why humans develop this very peculiar way of managing risks and elephants didn't. Because the structure up to the point when we finally get that question full frontal on the table, we've got there by walking through the comparative history of humans and elephants up to that point. And we find, again, similar species developing a lot of similar risk management mechanisms through natural selection and cultural selection in response to similar problems at similar times and finding convergent solutions. And then we get this divergence. And of course, where the divergence becomes enormous is when people start putting external signs into their environment. That's the point, of course, at which people now start scaffolding the environment to fit their form of intelligence in a way the elephants never do. So it's a very, very crucial part of the story, that divergence, and we focus a lot of attention on it. And we explain it in multiple ways, which are supposed to, we don't try to tell a single overarching story about it. We try to assemble a bunch of considerations that conspire to explain why that's the point at which humans go one radically different way than elephants a radically other way. And we think, yeah, the structure of the brains is an absolutely crucial part of the explanation, right? That one of the reasons why external scaffolding is such a great problem solution for humans, why it's one that human community after human community after human committee hit on in one way or another, was because of this fantasy risk we have to cope with. The risk of all having collectives, of sharing and amplifying crazy beliefs. And of course, one way of coping with that is put records of your beliefs in the environment where they stay put. Right? Record your take on the environment in a way that is not itself subject to endless shifting under your cultural dynamics. You still, of course, need enough continuity to be able to remember what the sign, to agree collectively on what the signs mean. But as long as you've got just that much stability, the signs can ground you. And then we make the point, well, elephants, so why didn't elephants do that? Why did elephants never start scaffolding their environment in our special human way? They weren't under any pressure to do so because elephants have extremely stable collective memories. They're stable across generations. They're also stable across populations, right? They have long distance signaling capacities that we don't have. So they can spread information about the local environment more efficiently across populations, and they can transfer memories over generations in more stable ways because their records in their brain, the records their brains are able to cope with are more stable. So that's where the brain comparison is crucial. It's in explaining why we rely so heavily on scaffolding, and there was so much cultural evolutionary pressure to develop it, and elephants don't. One of the exercises we have in the book, which was the most fun part to write, we have what we call a science fiction interlude, where we imagine that elephants had developed civilization and people had not. And we have a bunch of elephant anthropologists, so elephant scientists who study people, explaining to a popular audience of elephants why humans never developed civilization. And the basic mechanism these elephants use, they say, well, look, they're very violent. And one of the things that makes them very violent is they're crazy, right? And they describe the human brain, and they're extremely smart. They're really, really smart. They've got super expensive brains. They do amazing things that we can't really do. But they can't scale up their risk management problems. They can't scale up because they can't form large-scale societies because they're mad. And they cripple themselves with warfare and conflict and so on as a result of that madness, and they do insane things. And furthermore, the elephants then speculate on how humans, if they had developed civilization, might have how the sequence might have gone, and they see a sequence that makes no sense to them. They think, these humans with these overpowered imaginations, right? They have trouble keep doing statistics properly. How are they going to develop science without doing statistics properly? And of course, it never occurs to the anthropologist that you might have Galileo and Newton before you can do statistics, because that wouldn't happen to them. I should stop. I could go on and on.
Yeah, we have Michiru.
Yeah, so I'd like to continue with the same point. So how would you, I still kind of, although it's fascinating, I still have a issue understanding this craziness part because, the hunter-gathering and all these, small-scale societies, they don't have writing systems. And but was there some kind of a plausible story how their society faced that sort of craziness reality where the scaffolding is needed and then invented? Because as far as I can see from the surviving hunter-gathering people, they might have some crazy ideas, but I don't know what exactly is the sort of a ecological or evolutionary pressure for them to switch to the scaffolding with the collective memories by writing. So that's my question to
Great,
continue.
thank you. Yeah. Look, of course, one has to be a long record of scholars who embarrassed themselves reminds us to be very, very cautious about making generalizations about hunter-gatherers, because there are many scales of hunter-gatherers. Hunter-gatherers at different times in history are very different from each other. Hunter-gatherers under different climate conditions are very different from each other. And of course, there's and as archaeologists and anthropologists have shown us, there's a very large range of actual patterns that we can't explain. That is, we by no means explain all the variation we actually find in the record. So there's unexplained variance. That said, the problem we can make, I think a general point can be made. The problems confronted to us by our tendency to be crazy are much easier to control in an environment where everybody's observing each other most of the time, and they're also all observing a common environment. Right? I mean, right? Contrast a large scale or complex society with a small scale one. In the large scale society, almost everything you know that's really important about that society, you know on the basis of testimony multiple times removed from the relevant observations. So a much greater role is played by interpretation and by the kinds of generalizations about observations that require imagination to frame. In a small scale society where everybody is basically has a lot more shared, then of course everybody has some private information in any human group. But the proportion of the relevant information, the information relevant to basic coping and risk management in a small group, a much larger share of that will naturally be public information. And thus there's less scope for difficult to control imaginary processes from distorting it. Now, that's not to say, however, that even being small scale and everybody knowing everybody and everybody sharing a pretty common daily round of observations, that's not to say that gives you immunity from being mad in the way humans are mad, because of course the anthropological literature has plenty of examples of small scale, including hunter-gatherer societies, that went extinct because they adopted cultural practices which appear to have been, and the evidence strongly, the outcome strongly suggests, were deeply, deeply maladaptive, right? And there's no shortage of those examples either.
Thank you. Next, we have Eric.
Thank you, Emra, and thank you so much, Don. That was terrifically clear and interesting. I love the part of the story that suggests that our poor grasp on reality is an important ingredient in the way we, succeeded in certain ways. But my question is, sort of thinking about this project in the general sort of ecology of trade books on the same or similar big picture schemes like guns, germs, and steel, and so on. Like, do you think of yourselves as like filling in a blank in the story you get in these books, or do you want to sort of assert that these other people are wrong and you're right? Or what's the relationship between other kinds of like grand stories that you get in the literature?
Great. Thanks, Eric. So one of the things we talked about when we were conceptualizing the book and took a deliberate decision not to do was write the book as a kind of trade literature version of what goes on in academia, where you position yourself in competitive dialogue or in dialectic with a bunch of other people who've written at that level. We decided definite to not do that. We, of course, there are some authors engaged in projects at our scale who have also tried to engage the public, the wider public, who we rely on much more heavily than others. So there's a lot of Richard Wrangham in our story. There's a lot of Chaim Ofek in our story, and of course we acknowledge the externalist philosophers of cognitive science like Dennett and Clark. But in general, we don't. The most general answer to your general question is, and we are quite explicit about this in the opening chapter, we see ourselves as, filling in a missing piece. And that in particular, we don't find any of the existing popular accounts have really understood risk in what we see as the full-blown scientific sense. That, I mean, everybody understands risk in the colloquial sense of, a probability that some terrible thing could happen. But of course, that's not really the scientific conception of risk, which includes equal attention to upside risk as downside risk, and which is alert also to first order risk, second order risk, third order risk, and so on, right? To the difference between uncertainty, between prudence and risk and so on. So yeah, we try to be pretty clear about that we're not trying to position ourselves as antagonists of anybody's particular story. It will follow from some aspects of the specific features of the story we tell that it's not compatible with some other people's stories. I mean, I don't think our story is compatible with what Chomskyians say about human cognitive history, for example. But that strikes me as a good thing. I can't, Noam Chomsky, it's excellent that Noam Chomsky exists because he's always wrong about every big thing he ever says. And so you can use him as a kind of barometer.
Thank you so much. Thanks.
Thank you. If there are no other questions, we can. Uskali has a question. Go ahead, Uskali.
Okay. Right, here I am. Whether you can see me, I'm not sure.
We can see your hand.
Okay. Now, okay. Here we go.
There's your face. There's your
Right, here I am. Okay. Yeah, this was absolutely fascinating and appropriately speculative too. I love that. So here are a couple of further speculations in terms of questions. One is that the standard response that we hear much of the time about whenever humankind is kind of faced with major issues, problems, concerns, worries, whatever, is to refer to the capacity to imagine. Okay? I mean, we have the capacity to innovate, to invent new things, to exercise technological and institutional innovation and so forth. That's I mean, referring to the past, this is has always been the way of getting out of our problems, and then projecting this to the future. This will be the way out of our current predicament as well. So are you now suggesting that we have reached a limit? So this projection is incorrect. So this is one way of putting that question. So that argument won't work anymore. And the second question has to do with the elephant. Might it have been that had we humans been wise enough somehow to collaborate from the start with the elephant, joining our brains with those of elephants, we would not have developed the problems that we have actually developed. And then thinking of something that I think you did not mention at all, namely artificial intelligence. Isn't there something elephant-like in artificial intelligence? And then the question that we might pose here is to ask whether collaboration between human brains and artificial intelligence in the future is that going to amplify our problems or maybe contribute to their mitigation?
Okay, that was quite a lot. So, and I might need your assistance in remembering all the problems because there were three questions. One about limit, one about had we teamed up with elephants from the get-go, and then AI. First, then on the limit thing. So, in one sense, we're suggesting a limit, but in another sense, not. Right? So, let's start by the sense in which we are suggesting a limit. We, of course, I'll spend lots of time in the book talking about the remarkable innovations in our history of risk management. And also addressing the fact that we have these remarkable innovations and elephants do not, and that's why we're the apex species and they're on the brink of extinction. We notice this recurrent feature, though, of those major innovations, that they keep scaling up the risk. Right? There's a pattern in these innovations. It's not, they don't just wander randomly across risk space. They create this ratchet, and they create the ratchet at multiple scales. And the nature of that ratchet is such that once everything is bundled into one portfolio, how do you continue that strategy from a risk point of view? And that's a kind of limit. Now, on the other hand, though, there's another sense in which we're not hypothesizing a limit. I take it that an ultimate limit for humans would be extinction. And we think it's very unlikely we're going to go extinct. Precisely because people are very, very, people are good at finding local risk management strategies, including new ones. They're highly adaptive. In fact, we are arguably the most adaptive species, certainly mammal, possibly a vertebrate. And so we think it's overwhelmingly likely that even in the face of civilizational collapse at smaller scales, people will find ways to cope, and they will find new technologies that it would be, I think, truly foolish to speculate about, because you're changing too many assumptions now when you try to imagine people in those situations. Undoubtedly, there are future geniuses who will have great ideas we haven't thought of. In that sense, it's not a limit story. Had we teamed up with elephants at first, that's a wonderful idea, Yuskali. I have not thought of that before. I mean, we're trying to team up with elephants now, but we should have. It's a great thought experiment. Had we, we do in the book, of course, talk a bit about how humans did team up with another important species, namely dogs. I mean, dogs were a really important technology at one stage in human evolution, possibly crucial. And that was a true team story. And we say something about the cognitive and social capacities it showed in humans that we were able to manage our side of that team. There are hints, of course, of that kind of teamwork in India with mahouts and elephants. But, of course, it's not really teamwork. It's enslavement of elephants by humans, even in where the elephants are nicely treated. I won't say more about this except to note that if you're one of those people who thinks that humans are clever enough that if they're confronted with an important feature of their environment for long enough and with enough people involved, they will sooner or later figure it out. Let me say something about African people and African elephants. 30 years ago, you would have been told by anyone in Africa that African elephants could never be tamed in the way that Indian elephants are, because they would say African elephants are just too violent. Right? You just can't get them to be reliable enough to work with people in the way Indian elephants do. Now, absolutely nobody says any such thing. And everybody figured out at more or less the same time why that isn't true and what had been going wrong. So elephants are so important in African culture that elephant is one of the 10 words which has the strongest linguistic similarity across languages. Right? That is, we can see that the word for elephant in different African languages has an ancient common root, and it's the 10th most. It's when you list words in terms of their age, the age of their roots. Elephant is 10th on the list. It's up, and it's the only human culture that has an animal in that top 10. So elephants are pretty important, it seems. But people never figured out the following simple thing until just lately. If you're trying to get an elephant to cooperate with you, it must be 100% carrots, 0% sticks. No elephant will tolerate being punished by a human. but they're perfectly happy to get rewards. And they're perfectly happy to form friendships with humans if there's a consistent, if things go well. And in fact, you form quite reliable friendships with them. They're good friends when they're friends. So we could have teamed up with elephants, but we at least in Africa, that bit of stupidity got in our way. We kept trying to, yell at them or poke them or smack them. And that was a disastrous strategy. And lastly, about AI. Does modern AI or the kind, and by AI, I will take it to usefully mean the connectionist-based deep learning systems, not AI classical GoFi of the 1970s. These AI systems that are likely going to transform are transforming our economies now. Are they like elephants? In some ways, yes. In some ways, not. Look, one of the key. Think about the nature of Bayesian learning. If you have a brain like an elephant, right? Because you don't have significant decay of old data, your Bayesian updating is really, really conservative, right? Because you're not dropping old observations. You're not forgetting your old data. So if there are very subtle statistical patterns in the environment, can get completely locked in ways that don't happen to us. That's one of the reasons why we're better at imagination. Elephants get a bit stuck. Now, we could, of course, build a deep learning version of an elephant. It would be straightforward, right? And the main control parameter that would make a deep learning system more elephant-like or less elephant-like would be the decay rate on old evidence. So it's in the learning rule. Every AI implements a learning rule. Of course, it often implements more than one learning rule, but there's ultimately a grand learning rule at the basis of the more specific ones it might implement for more specific problems. And you could make that learning rule elephant-like, but probably AI designers will not, right? Because they're not likely to want very conservative AI systems. They're probably going to want AI systems that are either no more conservative than we are, or perhaps, I'm sure, Elon Musk dreams of AI systems that are as reckless as he is. And maybe he'll foist such AI systems on the rest of us. And then they won't be like elephants at all. Even madder people, even crazier people than we already are.
Yeah. Beautiful.
Thank you very much. When you started talking about scaling up risk, I was wondering whether Elon Musk will come up during the seminar, and it happened right at the end.
Well, I'm sorry about that. We don't want to be thinking about him any more than we have to, and we have to far too much.
But we have come to the end of the seminar. I would like to just remind you that this was a part of the ReSES Argumenta project. Don, this was really fascinating. So thank you very much for agreeing to do this. And thanks everyone for attending. So thank you.
Thank you all. Thanks to the audience very much. Thanks for the great questions, everyone. Thank you. Bye.